Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of derivatives to make a rough sketch of prime of f at x. So as per the problem, for the graph of function f at x, make a rough sketch of prime of f at x. So we are given these four graphs, and each of these graphs is for function f at x, and all of these are polynomial functions. So there's a linear function, quadratic, cubic, and quartic function. Now for polynomial function, we need to understand and memorize a property of derivative, that for a polynomial function, the derivative has a degree which is one less than the degree of the polynomial function. So what that means is that the degree of prime of f at x is 1 less than degree of f at x. So this is a very important concept you need to understand and memorize about polynomial functions. So let's start with the first function. Now the first function is a linear function. So for a linear function, we know that the degree is equal to 1. So that means the degree of prime of f at x will be equal to 0, because the degree of prime of f at x should be 1 less than the degree of f at x. So therefore, prime of f at x is a constant function for this linear function. So a constant function is a function which is written as just y equals a number. So I can write it here. So prime of f at x is a constant function which is written as y equals a number. So now we can analyze this graph. So now as you can see, this graph is a straight line, and the derivative of a function represents the slope of the tangent. And for a straight line, the slope is the same throughout. So that means the slope of the tangent at any point of this function will be the slope of the straight line. So there is a very important concept you need to understand and memorize. So if we can find the slope of the straight line, then we can use that to find out the equation of the prime of f at x, which we can use to make the sketch of the derivative of f at x. Now to find the slope of the straight line, we can identify two points that lie on this line. The first one is this y-intercept, the other one is this point here, which is 1, 3. So between these 2 points, the rise is 2 and the run is 1. So that means the slope of this straight line is 2. So that means the derivative of this function is a horizontal line that passes the y-axis at 2. So we can draw the sketch of prime of f at x as a straight line, a horizontal line that passes through 2 on the y-axis. So this represents the sketch for prime of f at x. So we are done with the linear function. Now we can analyze the second function. Now the second function is a quadratic function, and for a quadratic function we know that the degree is equal to 2. So that means the degree of prime of f at x for this function should be equal to 1. Now degree of 1 means that the prime of f at x is a linear function. So now we can see that in this given graph of f at x, so there is a local maximum at x equals 1. So that means at that point there should be the x-intercept for the graph of prime of f at x. So the first point for the prime of f at x is this x-intercept. Now on the left side of this local maximum, or in this case it's also the absolute maximum, the function is increasing because as we go from left to right across this parabola, so the function value increases all the way up to the local maximum. So that means the graph of the derivative to the left side of this x-intercept should be above the x-axis, because when the function is increasing, that means the prime of f at x is greater than 0. So that means the sketch on the left side of this x-intercept should go like this, a straight line. Now on the right side of this local maximum, the function is decreasing because it's sloping downwards. So that means the graph of prime of f at x should be below the x-axis to the right side of the x-intercept. So the graph should go like this. So this straight line is a rough sketch of prime of f at x. Now we can analyze the third function, which is a cubic function. So for a cubic function, we know that the degree is equal to 3. So the degree of prime of f(x) should be equal to 2, 1 less than 3. So that means, so prime of f at x is a quadratic function. That means the graph of prime of f at x should be a parabola. So now we can analyze the given graph for f at x. So the given graph of f at x has its local minimum at x equals -1. So that means there is an x-intercept for prime of f at x at x equals -1, because at x equals -1 the tangent is horizontal to the given function. So it's the same thing for the local maximum at x equals 2. So there is another x-intercept there. Now we can analyze the intervals in which the given function is increasing and decreasing. Now to the left side of -1, the function is decreasing because as we go from left to right towards x equals -1, the given graph is sloping downward. That means the graph of prime of f at x should be below the x-axis to the left side. So that means the graph should be like this. Now between -1 and 2, the given graph is sloping upward from left to right. That means the function is increasing. So the graph of prime of f at x should be above the x-axis between -1 and 2. So we can graph that as like this. And on the right side of 2, the given graph is sloping downwards from left to right. That means it's a decreasing function in that interval. So that means the prime of f at x should be below the x-axis to the right side of x equals 2. So we can extend our graph like this on the right side. So this red graph represents prime of f at x. And it's the same for the straight line we got from the previous function. Now we can analyze the fourth given function. So the fourth given function is a quartic function. So for a quartic function, the degree is equal to 4. That means the degree of the derivative of this function is equal to 3. So that means the prime of f at x is a cubic function. So now we can analyze the given graph. So we'll start by analyzing the local maximum and minimum. So there is a local minimum at x equals -2. So that means that is also the x-intercept for the derivative graph. Now there is a local maximum at x equals 0. So that means that's another x-intercept for the graph of the derivative. And then there is another local minimum at x equals 3. That means there's another x-intercept for the prime of f at x. Now we can analyze the given graph. Now to the left side of -2, x equals -2, the given function is decreasing because the graph is sloping downward. That means the graph of prime of f at x should be below the x-axis, because for decreasing function in an interval, the prime of f at x is less than 0. So we can draw a graph on the left side of -2 like this. Now between -2 and 0, the graph is increasing because as we go from left to right, the graph is sloping upward. So that means the graph for prime of f at x should be above the x-axis between -2 and 0. So we can show that like this. Now between 0 and 3, the graph is decreasing because as we go from left to right, the given graph is sloping downward. So that means the graph of prime of f at x should be below the x-axis. So we can show the graph like this. Now to the right side of x equals 3, the graph is sloping upward, so the function is increasing. That means the prime of f at x graph should be above the x-axis. So on the right side of x equals 3, so we can extend the graph like this. So this is the rough sketch of prime of f at x. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand and memorize that for a polynomial function, the derivative has a degree which is 1 less than the degree of the polynomial function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.